So we've summarized our data and generated a pivots table, and we've worked out the chi-squared value. The p-value associated with the chi-squared is very, very small, so we reject the null hypothesis. Now, how can we go that little step further and work out confidence intervals for the probability of success and failure in either of the two groups? So for this we need to work out confidence intervals, and the textbook that I'm using is this one here. This is Statistical Confidence by Douglas Altman, and I strongly recommend that you get this book if you want to do any calculations of confidence intervals. It explains very well the theory behind them and how to do it. It's very readable. So we're going to use the formula in this, and what I've done is I've simply copied out the formula. Page 46 of this textbook, it's in this chapter on confidence intervals of a proportion. And this is the formula that we're going to use. Okay, it looks a little bit forbidding, but I'm going to simply copy this over. So we control copy. I'll bring it into Excel so I can see it, and it's right next to us. Okay, so this is the formula we're going to use. So we need a number of things to calculate these values for A, B, and C. But all these symbols are all things we have here already. So let's just show what each one is. First of all, N is the number of trials. Okay, so it's the number of patients in each group. So for this one here, it's simply this cell here. So it's B8. Okay, equals B8. Okay. R here is the number of successes. Okay. Okay, so that's the number who recovered in each group. So it's cell B6. Okay, I'm only looking at group A for the moment. Okay, so there are 27 successes. P is the probability of success. And that's the estimate from the data we have here. So it's simply, it's the number of successes divided by the total number of trials. Okay, 0.27. Q is the probability of failure. Okay, and that's simply 1 minus P. Okay, so those are the basic numbers. Okay, well, now there's another Z. Z is how we express the confidence level. Okay, so that's the number in relation to what level of confidence we want. If we want to have a 95% confidence level, then this is how we get the Z. Okay, so it's from the normal distribution, normal standard inverse. So norm S in. So it's the standard normal distribution as the inverse. Now we want a 95% confidence interval. So that means we want the interval that stretches from 2.5% on one side to 97.5 on the other side. So it contains 95% of the probability. So I'm going to use the value at 0.975. Okay, and close the brackets, and we get a value of 1.95. It's fairly close to 2. It's not quite 2 standard deviations, it's 1.95. Okay, so that's our value for Z. Okay, now we're going to put in these equations here. So A is 2R plus Z squared. Okay, equals 2 times R, which is this one, times, times it's plus Z squared, Z, so we square it. Okay, that's a value for A. And the value for B is so B is Z squared Z squared plus 4RQ. So let's put that in. So B equals Z, which is this one here, multiplied by the square root of Z squared plus 4 times RQ. 4 times R is the number of successes times Q is probability of failure. And we close the brackets. That's our value for B. And our value for C. Okay, the formula for C is 2 into n plus Z squared. Okay, so it's 2 times brackets n is the number of trials plus z squared. Close the brackets. And that's the value for c. So we have a, b, and c, and now we use these two formulae here to get the actual confidence interval. Okay, so the upper bound is a plus b over c, the lower bound is a minus b over c. Okay, so the upper boundary is a plus b over c. Okay, so it's a, sorry, brackets first of all, a plus b, close brackets, divided by c. Okay, and our lower boundary okay, so that's a minus b over c. So let's just open brackets first. A minus b, close brackets, divided by c. And there it is. So that is our confidence now. But to make that into a percentage mark, so it looks like a percentage, and add in this difference here. Also, these two probabilities here will express them as percentages as well. Okay, so I'm going to highlight these in yellow so it's easy to see. These are the results of our analysis. This is the confidence interval. So for group A, my observed probability of success was 27%. Okay, that's 27 out of 100. My confidence interval for that is I'm saying that the true population success rate for group A is somewhere between 19% and 36%, and that is my confidence interval. So that's how we do it. Now, having put in the formulae once, it's dead easy to do it again for the other group. We just extend this down here, drag it across, and we do exactly the same calculations for group B, and we get the same thing. So in group B, we find our success rate was 8%, and our confidence interval is somewhere between 4.1% and 15%. Now you'll observe that the confidence interval for group B is from 4 to 15, for group A is from 19 to 36. So the two do not overlap. Okay? So because the two do not overlap, that means we can be very certain that the two are different, which of course is what the chi-square test tells us. But the confidence interval tells us much more. It gives us an estimate of how successful group B is and how successful group A is. So that is the effectiveness of confidence interval. It tells us much more than the hypothesis test does. But now I want to ask a further question. I can see, well, A and B have a difference. The one rate is different from the other. Let's just write it down. So the difference in success rate between group A and group B is that minus that. Okay, so the difference is 19%. Now obviously there's going to be a confidence interval around that. We observed a difference of 19% in this experiment, but there's a confidence interval around it. How can we work out what that is? Well, again, let's go back to Dr. Altman's book. This is the formula that we use for the confidence interval of the difference. Okay, now I'm going to again copy this across into Excel so I can see it near where we are. Okay, so this is the formula that I'm going to use. I'll move that one out of the way. Okay, this is the formula for the confidence interval of the difference. Okay. Now again, it looks a little bit forbidding, but we do actually have all the data already. All we need to do is put the numbers in. Okay, so our upper boundary. Okay, the upper boundary is this one here, d plus square root of all this. Okay, so I'll put the formula in, equals d is just the difference, plus the square root. Okay, and we have open brackets again. So it's, the formula is P2 minus L1. So P2 is this one, minus L1 is the lower boundary. Sorry, I said P2 minus L2. So P2 is the probability for group 2. L2 is the lower boundary for group 2, which is that. Close the bracket and square it. Okay, then plus, open brackets again, and it's U1 minus P1 squared. So U1 is the upper boundary for group 1, minus P1 is the probability for group 1. Close the brackets, square that, and then close the outer brackets. And that's my upper boundary. Okay, and then my lower boundary. Okay, so the formula for the lower boundary is D minus all of this. So D is 19% minus square root. And another set of brackets open up. So it's P1 minus L1 squared. So P1 minus L1, close the bracket and square it. Okay, plus U2 minus P2 squared. So open brackets again, and it's U2 minus P2. Close the brackets and square it, and close the outer brackets. Okay, so again I'm going to make this into a percentage. And I'll add some figure. Okay, and I'll highlight all of that. So this here is my confidence interval for the difference in success rate for the two groups. So my observed difference is 19% in my sample, and I work out a confidence interval. I can say with 95% certainty that the difference between group A and group B is somewhere between 8% to 29%. Okay, so at the very minimum I can say that group A is 8% more effective than group B, but it could be as high as 29% greater. That's what the confidence interval means. So this calculation here is the confidence interval for the difference in success rate, whereas my previous calculation is the confidence interval for the success rate in either group. And that is how we work out our confidence intervals. We can also work out from this the number needed to treat. So, for example, if I want to know the NNT number, how many do I need to treat in order to get one extra success? This is a very easy calculation. It's just the inverse of the difference. So it's just 1 divided by that. Okay, 5.2. So that means in order to get one extra success, I need to treat 5 patients. What's my confidence interval for it? Well, again, I'll just drag the same formula down here. Okay, so my confidence interval for that, okay, is somewhere between 3 and 11. Okay, so I have a confidence interval not only for the difference in success rate, but also for the difference in my numbers needed to treat. I can say it's somewhere between 3 and 11 patients. Okay, so when I know the confidence interval and my difference, I can work out the NNT as well.